Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we have did a derivation which was based on the work done during the expansion of gas. But yes, this work could be maximum also. How? Let us talk about it. So now we are going to discuss about the concept of maximum work. So let us start with the first point, that how the work done during the expansion or in any process would be maximum. So the first point is, when a certain change takes place, the amount of work done by the system depends on the opposing force. Yes, in the last lecture also we have did this thing where we have got to know that when W is equals to minus PEX, that is the external pressure, into change in volume. So in this case what we have observed is that the work depends on the opposing force. If the opposing force is more, then the work done could be maximum. So, or it depends on the pressure, actually the external pressure or the opposing force. So it depends on that case that we have did here, that is the opposing force. So now talking about the next one, that is, if opposing force is zero, no work is involved, and more work will be done if opposing force increases. So these are the two statements that I'm going to focus on. So the first statement, which says that if opposing force is zero, no work is been involved. So if opposing force is zero, so suppose consider the same thing that we have did in our earlier lecture, that is for derivation of expansion of gas, that we have took a cylinder which was enclosed with a gas, and upon that a frictionless piston was placed on it. So suppose if the opposing force is zero, suppose if I am not applying any kind of external force to the system, that is to the gas which is present in the cylinder, so basically no work will be done. Or suppose in that case, suppose if pressure is been if we have to apply, and if I'm not applying any kind of pressure, then obviously the gas won't expand. Or suppose if I'm talking about, suppose if the condition has been set in a vacuum condition, so what will happen, even though the pressure has been, because of this vacuum, pressure is zero, so obviously no work will be done. The gas will expand, but the work will be done zero. So it clearly indicates that the work depends on the external pressure. So moving towards this statement, more work will be done if opposing force increases. Yes, this is the statement which was based on the previous derivation that we have did, that if opposing force increases, or if opposing force has more value, not like the vacuum condition, so the work done during that process will be also more, and in that case only we will find the maximum work done by the system. But there are also few conditions that opposing force should not be more than what. Let us see the next concept. So in this case, when opposing force reaches its maximum value, the system does maximum work. That is what we have discussed in point number second of this concept of maximum work. So because the opposing force is more, and more effort is needed to overcome it, and that is true. Suppose if opposing force is more, suppose I am always even though if we apply more pressure to the system, which is nothing but the gas that we have took the example in our previous section. So if opposing force is more, then the gas will try to expand, gas will oppose it so as not to get compressed. So even the gas has been expanding, so it will oppose the opposing force that is being applied on it, and hence the work would be done. So that is what this was talking about. And yes, the opposing force value should be more, then only the maximum work would be done, because no pressure means, or no opposing force, no work will be done. So it depends on the opposing force. So the next thing is, if opposing force becomes greater than the driving force, the process gets reversed. Yes, this is what I want to talk about mainly, so that you won't get confused in this case. Suppose if the gas has been present in a cylinder, and if you are applying the force, that is opposing force, if you are applying through the surrounding, and you are making the gas to get compressed, so what will happen, the piston will move down, as well as we could see that the volume will get reduced. So this is only possible if the opposing force is more. And what is driving force actually? The driving force is nothing but the gas which tries to expand. So in this case, basically the gas will try to expand, and even though if you are applying pressure, so if both the pressures are, that is the pressure of the gas and the external pressure that we are applying, if the both are same, then it's fine, there is no problem, because the gas won't get compressed. But in this case, suppose if opposing force is more than the driving force, that is when the gas is expanding, so in this case obviously one thing will happen, that the gas will compress. So instead of getting expanded, it will turn into a reverse, that is it will try to compress. So this is possible if opposing force is more than that of the driving force. Now let's move toward the next point. So point number 5 says that the opposing force cannot be greater than the driving force, but at the same time it should be maximum. So this, let me tell you about this statement. Because there are two kind of forces. One is the driving force and one is the opposing force. Opposing force is the one which makes the gas to get compressed, or which applies the pressure on the piston so as the gas would get compressed, while the driving force is somewhat which makes the gas to expand. So this clearly says that opposing force cannot be greater, because the gas is the one which wants to expand, and when we are talking about that as an example, so gas wants to get expand. So in this case, driving force should always be a bit greater than that of the opposing force, and if opposing force is more, then the work would not be done to a maximum limit. So but it should always be maximum, means opposing force should not be more, but it should be more till maximum work could be obtained. So now moving towards the next one, that is the point number 6, which says that maximum expansion work will be obtained if opposing force is infinitesimally smaller than the driving force. Yes, if the driving force is more than that of the opposing force, comparatively more than that of the opposing force, then obviously the gas will expand. But it is not sure that we would get a maximum work, just in case we have did in our previous derivation, that is expansion of a gas during isothermal and reversible process that we have did. So in this case, what happens is the driving force was more and more than that of the opposing force. So the work was been done, but the work was not maximum actually. So if you want to perform a work done during the expansion of gas, then the gas should have more force it should be more force, just an infinitesimal value than the opposing force. Then only what will happen, maximum work would be obtained in that process. So that's what it explains, that the opposing force should be infinitesimally smaller than the driving force. So now let's move to the next one, which says that this conclusion can be obtained from, yes, we are talking about W is equals to minus Px into delta V. If pressure of the gas P differs from Pex, means suppose if the pressure of the gas which we have enclosed in a cylinder, if it is being more, comparatively more than the external pressure, then what will happen, we could write it as delta P, that is the change in the pressure, will be P minus Px, that is the pressure of the gas minus the external pressure. So we could say that Px is nothing but minus P minus delta P, that is external pressure is nothing but P minus delta P. And if I draw or if I make this equation, that is W is equals to minus Pex into delta V, and instead of Px I am writing the value that we have did recently right now as P minus delta P into delta V. So let me talk about this thing, that is delta P. Suppose if the difference is more, so what will happen? If the difference, that is if delta P, that is the difference between the pressure, is more, then what will happen? This value, that is P minus delta P, it will be negative, and this negative value will lead to the overall work to be positive. And if the work is been positive, that means surrounding is been doing work on the system and the gas will compress. So therefore there is no work done by the system. So if we want to make the work to be maximum, then what we should apply a condition as the change that we observe between the pressure of the gas and the external pressure, that should be minimum. So if the more the minimum value of delta P, so if delta P is less, very much less than that of the P, then we could say it as the value will be if delta P is very small, infinitesimally small. So what will happen? The work will be is equals to minus P into delta V. This is infinitesimally small value. So in this case, what we can observe is as the work could be maximum. The work could be maximum. So that is what this talks about. That whenever the external pressure, there are two kind of force as we have discussed in the previous points also. That one is driving force and one is opposing force, but they should have difference only a bit, a very small difference. That is infinitesimally small difference between them. And if we have to perform a maximum work during the expansion of by the system to the surrounding, then in that case the driving force should be infinitesimally more, having a more value than that of the opposing force. Then only maximum work would be done. So this is what we have, what I was talking about. So now let us move on towards the next one, that how are the conditions that we should maintain so as to perform a maximum work. So these are the thing. So basically, yes, this is nothing but the condition of maximum work. So it says that any change that takes place in a system should be thermodynamically reversible. Thermodynamically reversible. So this kind of thermodynamically reversible topic we have did in our earlier lectures also. So for that instance, let me give you a small synopsis while explaining this diagram. So suppose if this we have to perform a maximum work, or we are talking about the work done that should be maximum. So there are two kind of forces, as you could see, that is the external pressure and this pressure. So let me consider that this pressure is the driving force while this is the opposing force. So in this case, the both are almost equal to each other, and the thing is, if we have to perform a maximum work, then this system should be thermodynamic equilibrium. It should be thermodynamic equilibrium. That is, we know that in thermodynamic equilibrium, the conditions or the state functions like pressure, the volume, and the temperature, it doesn't changes a lot. It will remain almost constant. So therefore, this system should be overall in a thermodynamic equilibrium. That is the first thing to maintain the maximum work done during the for the system during the expansion of a gas or during any kind of system. So this is the thing that we have made. Now moving towards the next one, that is the change in the system should take place in an infinite number of steps. Yes, there should be infinite number of steps while there should be change in the system. It should not be finite, it should be infinite, and more the infinite steps means more the maximum work will be done during by the system to the surrounding. So this is what they have talked about. And then next one is the driving force should be infinitesimally greater than that of opposing force. This is what we know already, and we did this kind of topic in our earlier lectures also. So this was the third condition to maintain the maximum work. And talking about the last one, it says that the system should be in mechanical equilibrium with the surrounding, because maximum expansion work is obtained when external pressure is only infinitesimally smaller than pressure or the pressure of gas that we have to in our earlier examples. So this is what the concept of maximum work was. Very easy, but understanding this was very much important, because this will make us to understand about chemical thermodynamics more and more. So thank you friends for watching this video. I hope you have got to know this topic very clearly, and yes, share this video with your friends, and don't forget to subscribe Ekeeda channel. Thank you so much.